Hello guys, welcome back. Myself, Assistant Professor Gaurang Prajapati from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. We are covering the chapter of direct and bending stress of the subject Structural Analysis 1, 4th Sem Civil Engineering. In the previous video, we have covered the theoretical portion of this chapter. Okay, this all theoretical portion and one example of core and kernel of the sections, because that was also theoretical criteria. Now in this video we are going to cover the typical examination, or we can say examples of the masonry piers which have been asked in the examination. Okay, so let's solve the sum first of all. Just a minute. Yeah, example number 2. See, a rectangle column of the width 200 mm and thickness 150 mm carries a point load of 240 kilonewton at an eccentricity of 10 mm as shown in figure. Now, figure is given to us. This is our figure which is given to us. Rectangle section 200 cross 150 mm. Then it is, let me zoom the figure first of all. Yeah, just a minute. See, this is our rectangle column which is given to us 200 mm cross 150 mm. These are its longitudinal axis. Okay, now the force is acting over here P, okay, at the distance of 10 mm, and force is how much? So we can say 240 kilonewton. So the value of the force is given, while this one will be our eccentricity Ex, or we can say 10 mm. Okay, okay, chalo, just a minute. Moving forward, so P is 240 kilonewton. Let's convert it into Newton. So 240 into 10 raised to 3 Newton. Eccentricity is 10 mm. And B and D, that is 150 cross 200 mm. Okay. Now determine the maximum and minimum stresses on the section. Okay, so we need to calculate sigma max as well as sigma minimum. So first of all, we have seen in the theory sigma maximum stress equals to direct stress plus bending stress. Direct stress stands for sigma 0, okay, that is P by A, while bending stress, that is sigma B, that stands for M by Z. Okay, so sigma maximum's formula is sigma 0 plus sigma B, while sigma minimum's formula is sigma 0 minus sigma B. So what we need to do, we need to calculate two stresses, sigma 0 and sigma B separately, and then one time add and one time subscription. Okay, so sigma 0 means direct stress, formula will be P by A. So ultimately I need to calculate P and A, while sigma B formula stands for M by Z. Okay, where M stands for P cross E, that is force multiplied by eccentricity, and Z stands for I by Y, Mi divided by Cg. So ultimately what I need to calculate to solve sigma max and sigma minimum, first of all I need to know the P will be given to us in the data. Next, area, we need to calculate area. Then we need to calculate moment, that is P into E. Okay, and then we need to calculate Z. For Z I need two values, moment of inertia and Cg. So ultimately in each and every example I need to calculate first one area, second Cg, and third its Mi. Once I get all these three values, then I will calculate moment, that is P into E, and then I will calculate the remaining one. So in each and examples we will do some similar this way. So first of all, just a minute, let's calculate the unknown parameters. Just a minute. See, now area stands for, obviously, for rectangle section, area cross B cross D, that is 150 divided by, multiply by 200. So we will get the area 30 into 10 raised to 3 mm square. Next, moment of inertia for the rectangle section BD cube by 12, that is B is 150, D is 200 cube by 12. So I will get the answer 100 into 10 raised to 6 mm raised to 4. And last one Cg, that is we can say for the rectangle section Cg is always at the center, that is we can say D by 2. So 200 by 2, I got the 100 mm. So I got area, Cg and Mi along with that one. Then we need to calculate moment. So for moment we can say P into E, and for Z I will get I by Y. So first let's calculate Z, that is I by Y. I, that is 100 into 10 raised to 6, and Y, that is 100 mm. This one. By simplifying this one, I will get 1000 into 10 raised to 3 mm cube, that is Z. Then the remaining one is M, that is P into E. Now P, that is given to us in the data, as well as eccentricity, that is also given to us in the data. So 240 into 10 raised to 3 into 10. So ultimately I will get the value of M, that is 2400 into 10 raised to 3 mm. So I got all the unknown parameters. Now let me calculate first of all sigma 0 and sigma b. So let's start it first one with sigma 0. Direct says sigma 0 equals to p by, now p, that is 240 into 10 raised to 3, see, and area we have calculated over here 30 into 10 raised to 3. So ultimately I will get the answer sigma 0, that is 8, and as it is stress, so unit will be Newton per mm square. So first, that is sigma 0. Now next, that is bending stress, sigma b. Formula stands for m by z. Now m, that is 2400 into 10 raised to 3, and z, that is we can say over here 1000 into 10 raised to 3, that is this one. By simplifying this one, I will get sigma b, that is 2.4 Newton per mm square. So as I've got this value of sigma 0 as well as sigma b, now we can calculate maximum and minimum stress. So first of all, maximum stress, sigma 0 plus sigma b, sigma 0 8, sigma b 2.4. So 8 plus 2.4, answer is 10.4 Newton per mm square, and as it is positive means it is a compressive stress. Let's calculate the minimum stress, sigma minimum. Answer stands for sigma 0 minus sigma b, sigma 0 8, sigma b 2.4. 8 minus 2.4, I got the answer 5.6 Newton per mm square. Again, as it is positive, so our answer is compressive. They have not asked us to draw the bending stress diagram. If I need to draw the bending stress diagram, okay, see, if it is our section A and B, so sigma b, at B point sigma maximum will be there, and at A point sigma minimum will be there. This one is sigma minimum value. Sigma maximum, that is equals to 10.4 as you can see, and sigma minimum, that is 5.6, and both are positive. So like this will be our bending stress diagram, but they have not asked us to draw the diagram, so I have not shown it over here. Okay, next sum. So first case, that is of the rectangle section. Now let's take any other section, say square section. Say first of all, let's just read out the data. A square column 400 mm side carries a compressive load of 400 kN as an eccentricity of 100 mm on x-axis. Determine the maximum and minimum stresses. Okay, now they have not given us the figure, so first of all we need to do the figure. Say a square section is there of 400 cross 400 mm. Okay, 400 cross 400 mm. Now any force P is acting over here, okay, at a distance of 100 mm from the centroidal axis. So this will become my eccentricity. Clear? And load is also given to us, I think 400 kilonewton. Yeah, and we need to calculate sigma max as well as sigma minimum. So we have done in the previous example also, we will do same way in each and every example. First of all, what we will do, we will calculate area, mi and cg. So area for the square section, b square, that is 400 into 400, or we can say 400 square. So I got the answer 160 into 10 raised to 3 mm square. Then moment of inertia for the square section, b raised to 4 by 12, 400 raised to 4 by 12. So I got the answer 2.13 into 10 raised to 9 mm raised to 4. And then talking about cg, and cg will be always at the center, that is b by 2, 400 by 2. So we got the answer 200 mm. So I got all the unknown parameters. Now let's calculate the main unknown parameters, that is m and z. Okay, so first of all z, that is I by y, just a minute. First of all z, that is I by y. I is 2.13 into 10 raised to 9, you can see over here, and z, that is 200 mm. Okay, by simplifying this one, I will get the answer 10.67 into 10 raised to 6 mm cube. Then another unknown, that is m, p into e. P is given there in the data, E is also given there in the data. Okay, 400 into 10 raised to 3, and E is 100. So we got the answer 40 into 10 raised to 6 Newton into mm. Okay, once I got this one, now we can calculate the remaining one. Sigma 0, that is P by A. P is 400 into 10 raised to 3, and area 160 into 10 raised to 3. See, let's put down the value. By simplifying this one, I will get the answer 2.5 Newton per mm square, that's sigma 0. Then sigma b, that is m by z, m 40 into 10 raised to 6, z, that is 10.67 into 10 raised to 6. Clear? By solving this one, I will get the answer 3.75 Newton per mm square. Now as I have got the sigma 0 and sigma p, first of all sigma maximum, sigma 0 plus sigma b, sigma 0 2.5, sigma b 3.75. So 2.5 plus 3.75, I will get the answer 6.25 Newton per mm square. And as it is positive, compressive stress. And sigma minimum, sigma 0 minus sigma b, sigma 0 2.5, sigma b, that is minus 3.75. Okay, by solving this one, I will get the answer minus 1.25 Newton per mm square. And as it is negative, so it is tensile stress. Okay, so if I need to draw the diagram once again, they have not asked diagram, but I will draw the diagram over here to show you. See, this is 0 0 line. At right hand side at b, sigma maximum will be there, which is positive, and at left hand side at a, sigma minimum will be negative. So this will be my diagram. Sigma maximum, that is 6.25, and over here sigma minimum will be there, that is 1.25 Newton per mm square. So this will be my bending stress diagram if they have asked us to draw. Okay, but right now they have not asked, so no worries are there. Now moving forward, next, in first case I took the rectangle, then square. Now in this case I will take the circular section. Just a minute. Yeah, see, a circular column 450 mm diameter carries a load of 600 kN at an eccentricity of 100 mm. Calculate maximum and minimum stresses of the column. So first of all, just a minute, let us draw the figure. Say a circular column is there, circular column, diameter, I think 450 is there, that is diameter. Okay, and force is acting at an eccentricity, force is I think given P 600 kilonewton at an eccentricity. I don't remember the value of eccentricity which is given to us in the data. Okay, so first of all we need to draw this figure. Now eccentricity is 100 mm. So first of all, as we have done in the previous examples, now force is given to us 600 kilonewton, so 600 into 10 raised to 3 Newton, eccentricity 100 and diameter 450. So like all other previous examples, first of all we will calculate area. For the circular section, area pi by 4 d square, pi by 4 450 square. So ultimately I will get the answer 159.04 into 10 raised to 3 mm square. That's the area. Then Ixx, for the circular section, moment of inertia formula is pi by 64 d raised to 4. So pi by 64 into 450 raised to 4. Simplifying this one, I will get the answer 2.01 into 10 raised to 9 mm raised to 4. And then Cg, for the circular section, Cg is always at the center, say at radius d by 2, that is 450 by 2, that is 2 to 5. So once I get the value of Ixx and y, I can calculate z, ratio of Ixx and y. Ixx 2.01 into 10 raised to 9 and y, that is 2 to 5. Let's put down value and calculate the answer. Answer will be 8.95 into 10 raised to 6 mm raised to 6. Then we need to calculate moment P into E. P is 600 into 10 raised to 3, while E, that is 100 mm. By simplifying this one, I got the answer M, that is 60 into 10 raised to 6 Newton into mm. Now by solving this one, means by putting down all this value in main equation, we will get the answer. Just a minute. Yeah, first of all, direct stress, sigma 0 equals to P by, now P, that is 600 into 10 raised to 3, while area 159.04 into 10 raised to 3. I got the answer 3.77 Newton per mm square. Next, bending stress, formula stands for m by z. M, that is 60 into 10 raised to 6, z 8.95 into 10 raised to 6. So I got the answer 6.71 Newton per mm square. Okay, then maximum stress, sigma 0, sigma max, that is sigma 0 plus sigma b, sigma maximum, sigma 0 3.77, sigma b is 6.71. So I got the answer 10.48 Newton per mm square, and as it is positive, so compressive. Similarly, minimum says sigma 0 minus sigma b, sigma 0 3.77 and sigma b 6.71. So by this one I will get the answer minus 2.93 Newton per mm square. Just a minute. 2.93, and as it is negative, so stress will be tensile. Once again, if I need to draw the diagram, then diagram will be sigma maximum at right hand side, sigma minimum as it is negative at left hand side, plus minus. This one is sigma maximum, value is 10.48, while this one is sigma minimum, value is 2.93. so that will be our diagram. Okay, if they have been asked, but they have not asked, so I have not shown it over here. Okay, so in previous all three examples we have taken rectangle, square and circular sections to calculate sigma max as well as sigma minimum. Now let's do some of the examples which are variable, means these are not the typical examples. Now in the following examples, either sigma max or sigma minimum will be given to us, and we need to calculate either diameter, or we can say eccentricity, or we can say force, like that. Okay, so example number 2, 3, 4 are the ideal or typical examination examples of the sigma max and sigma minimum, means maximum stress and minimum stress. Now let's solve some of the examples of the variable. Now, example number 5, a cast iron column having 150 mm diameter. See, a cast iron column is there whose diameter is 150, carries an eccentric load of 50 kilonewton. It is carrying an eccentric load, we can say P, of 50 kilonewton. If maximum tensile stress is not to exceed 7.5 Newton per mm square. Now tensile stress is given to us, okay, that is 7.5 Newton per mm square. Find the permissible eccentricity of the load on the column. So ultimately this time, see, let me just zoom the figure. See, yeah, see, this force is P is given to us, as well as we can say diameter is also given to us, that is I think 150. Okay, but this eccentricity is not given to us this time. We need to calculate this eccentricity, but instead of all the remaining data, they have given us maximum tensile stress. See, we have already discussed in the theoretical portion that tensile stress will be usually sigma minimum, because normally maximum stress will be always compressive. Okay, so let's see the data. Just a minute. See, now force, that is 50 kilonewton, so P 50 kilonewton, 50 into 10 raised to 3. Circular section is there. So diameter, that is 150 mm, diameter is also given to us, and maximum tensile stress means it is always meant to be sigma minimum. If it is given maximum compressive stress, then I will go for sigma max. Okay, always remember the word tensile stress. Tensile indicates usually minimum stress. Okay, and as it is tensile, so negative sign minus 7.5 Newton per mm square, and we need to calculate eccentricity. Okay, so what we will do in the example, that sigma minimum is given. So first of all I need to apply directly that formula, sigma minimum, that is equals to sigma 0 minus sigma b. Sigma 0 stands for P by A and sigma b stands for M by Z. So for that one, as we need to calculate eccentricity, so eccentricity's formula will be only M. M is respect to P into E. Okay, like that. So ultimately sigma minimum is there. We need to calculate the remaining unknown terms like we were calculating previously also. What we were doing until now, we were calculating area, CG and MI. Okay, so we will do the same parameters over here also. First of all, area. For the circular column, area is pi by 4 d square. So pi by 4 into diameter, that is 150 square. So I will get the answer 17.67 into 10 raised to 3 mm square. So area's problem is solved. Next, MI. For the circular section, MI equals to pi by 64 d raised to 4. Diameter is 150 raised to 4. So ultimately I will get the answer 24.85 into 10 raised to 6 mm raised to 4. And then we can say CG, that is we can say the center d by 2, or we can say R, that is we can say 75 mm. So I got all these three unknowns, and once I get the value of I and Y bar, I will easily get Z. So Z equals to I by Y. I is 24.85 into 10 raised to 6 and Y, that is 75. By solving this one, I will get the value Z, that is 331.34 into 10 raised to 3. Clear? Now that is Z. Then we need to calculate M. So for m we need the value of E, but right now eccentricity is unknown, so no worries, we will keep eccentricity as it is, P into E. P is 15 to 10 raised to 3, so 15 to 10 raised to 3 into E. So now I have all the unknowns parameter except eccentricity, so now I will go for the formula of sigma minimum. So now sigma minimum, sigma 0 minus sigma b, sigma 0 that is P by, and sigma b that is m by z. Now let's put down the value. Sigma minimum minus 7.5, P that is given to us 15 to 10 raised to 3, 15 to 10 raised to 3. Area we have calculated 17.67 into 10 raised to 3, okay, minus m that is 15 to 10 raised to 3 eccentricity, that is over here, divide by z that is 331.34 into 10 raised to 3. Okay, so now by solving this term, see 7.5 minus that is as it is, then by solving this term, okay, we will get the value of 2.83, and by solving this term keeping eccentricity as unknown, okay, so I will get the answer 0.15 E. Now in the whole equation eccentricity is unknown, so let's take this one to the opposite side, so it will become plus 0.15 E, and on the opposite side 2.83 plus 7.5, so I will get 10.33. So finally eccentricity equals to 10.33 divided by 0.15, so I will get the answer 68.45 mm. So see, this is one of the variations of the examples in which, as I told you, either sigma max or minimum will be given, and you need to calculate either force or diameter or eccentricity like that. Okay, I have shown some of the examples over here. Now next sum. Now this is one is also of the circular section. Example number 6. A circular column of the diameter small d, now diameter is unknown in this one, is subjected to load of 200 kilonewton at an eccentricity of 0.3 times d. See, force is given and eccentricity is also given, but in terms of d, that is 0.3 times d. So diameter is unknown for us. If maximum stress at the base of the column is not to exceed 50 Newton per mm square. Now in this one they have given the maximum stress. In the previous example also they used the word maximum, but they have used the word maximum tensile stress. That's why we took the sigma minimum. Okay, but in this example you can see the maximum stress is not to exceed 50 Newton per mm square. They have not mentioned tensile over here. That means this is the value of sigma maximum. If they use word tensile, then you can go for sigma minimum. Always remember this rule. Okay, so then find out the diameter of the column. We need to calculate the diameter. Okay, no worries, what they have given us, we will start sum from that one only. Circular column is there, force is given to us 200 kilonewton, so 200 into 10 raised to 3 Newton. Sigma maximum is given to us, that is 50 Newton per mm square. Eccentricity is also given, but in terms of diameter, and we need to calculate the diameter. So for that one, as we were doing in the previous all examination, examples, we will calculate the 5 unknowns. First of all, area, mi and cg, but the problem is diameter is not given. We are going to calculate diameter, so no worries, we will calculate all these terms in terms of diameter. So first of all, area, pi by 4 into d square. By simplifying pi by 4, I will get the answer 0.785 into d square. Then mi, pi by 64 d raised to 4, diameter is d. Okay, so by simplifying pi by 64, I will get the answer 0.0491 into d raised to 4. And then cg, that is always at the center, d by 2, so we can say 0.5 times d. So I got area, mi and cg all in terms of d. So I will calculate now z, that is I by y. I is 0.0491 into d raised to 4 and y 0.5 times d. By simplifying this one, I will get the answer 0.0982 d raised to q. Okay, then moment, p into e. Now p is given to us 200 into 10 raised to 3, while eccentricity is given in terms of diameter 0.3 times d. Simplifying this one, I will get the answer 60 into 10 raised to 3 into d. So I got all these unknowns in terms of d. So now I will go for the final formula, sigma maximum. Formula stands for sigma 0 plus sigma b. Sigma 0 that is p by a, and sigma b that is m by z. Now let's put down the value. See, sigma maximum that is given to us 50, so that's 50. P that is given to us 200 into 10 raised to 3, so 200 into 10 raised to 3. A, area stands for 0.785 d square, 0.785 d square. then m, that is 60 into 10 raised to 3d, 60 into 10 raised to 3d, and z 0.0982 into d raised to cube. Okay, so we have got all this value of this box. Now in this all equation only one unknown is there, that is diameter. So let's solve this one. Just a minute, let me zoom it. Yeah, now what we will do, 50 as it is. Now we will solve first of all this one, 200 into 10 raised to 3 divided by 0.785. So I will get the answer, that is this one, 254.65 into 10 cube divided by d square. Then in this equation also we will do the same manner. Just a minute, this one, 60 into 10 raised to 3 divided by 0.0982. So I will get the answer 611.15 into d 10 raised to 3, and this one d divided by d cube, that is d square, and over here also d square as it is. So by taking d square as a common, I will multiply d square on the opposite side. So ultimately it will be 50 times d square while solving these two as a summation. Okay, so I will get this one, 865.8 into 10 raised to 3. Okay, that is equals to 50 times d square. So I will get first of all d square from this one. Okay, divide by 50 like that. So 17316.06, and by doing the under root of this one, I will get the value of d, that is 131.59 mm. Clear? So I hope so you are getting the concept of the examples. As I told you, either of sigma max or sigma minimum will be given to you, and we need to calculate the remaining examples. Now example number 7, a hollow circular column. Just a minute. A hollow circular column having 200 mm external diameter and 120 mm internal diameter, say 200 mm external and 120 mm internal diameter, is subjected to an eccentric load of p kilonewton, due to which maximum and minimum stresses are developed at the base of the column are 100 Newton per mm square and 20 Newton per mm square respectively. Calculate the value of load P. See, we have done all the examples before earlier also. In one of the examples we calculated eccentricity, in one of diameter. Okay, like that. Now in this example what we need to do, we need to calculate the P. Now in this one, maximum and minimum both stresses are given to us, as well as the dimensions of the column are also given to us. Okay, so let's just write down the data which is given to us. See, hollow circular section is there, outer diameter and inner diameter is given to us, as well as sigma max and sigma minimum both are given, and they have not mentioned tensile, so both are positive right now, and we need to calculate, that is P. So first of all, as sigma max is given to us, so we know that sigma max equals to sigma 0 plus sigma b. Okay, so I will get sigma maximum, that is 100. So I will get the first equation, that is this one, sigma 0 plus sigma b equals to 100. Then similarly, sigma minimum equals to sigma 0 minus sigma b. Sigma minimum is given to us 20, so sigma 0 minus sigma b equals to 20. So I got two equations, this one. Now by adding, or we can say solving this one, I will get one of the values from these two. So let's come over here in this one. Say, first equation, sigma 0 plus sigma b equals to 100. Second equation, sigma 0 minus sigma b equals to 20. By solving this one, I will get 2 times sigma 0 equals to 120. So sigma 0 equals to 120 by 2. So I will get 60 Newton per mm square. But they have not asked us to calculate sigma 0. They have asked us to calculate, we can say, P. Now as I have got the sigma 0, we know that relation sigma 0 equals to P by A. So if I get the value, I already have the value of sigma 0. If I get the value of area, then I can easily calculate the P. So for area, for hollow circular section, we know that the area equals to pi by 4 capital D square minus small d square. We have the values of both one. So pi by 4, 200 square minus 120 square. So I will get the answer of area, that is 20106.19 mm square. Okay, so now I can apply the formula of direct stress, sigma 0 equals to P by. Okay, let me just zoom the figure. Okay, so for that one we need to calculate sigma 0, that is 60 Newton per mm square, which we have got the answer. Just a minute. Sigma 0, that is 60, and area, that is 20106.19. By solving this one, we will get the P, that is 1206.37 into 10 raised to 3 Newton. Let's convert it into kilonewton, that is 1206.37 kilonewton. Okay, so that's the case of P. Okay, now in this example, sigma max and minimum both were given, so we will solve some in this manner. Okay, now similarly, one example is there. Example number 8. A circular column section carries an eccentric load of 100 kilonewton with an eccentricity of 20 mm. So force is given 100 kilonewton, 100 into 10 raised to 3 Newton. Eccentricity is also given, that is 20 mm. Find the diameter of the section if maximum and minimum resultant stresses are 10 Newton per mm square compressive and 4 Newton per mm square tensile. Tensile means it will be negative. Okay, respectively. So now in the previous example we calculated the P. Now in this example we need to calculate the diameter. Okay, chalo. Let's write down the data. Circular column is there, P is given to us, eccentricity is given to us. Now sigma maximum, that is 10 Newton per mm square compressive, so it is plus, and sigma minimum, that is 4 Newton per mm square tensile, so it is minus, and we need to calculate D. So as we have done in the previous example, we will do the same manner over here. First of all, generate the two equations. Sigma maximum equals to sigma 0 plus sigma b. Sigma maximum is given 10, so sigma 0 plus sigma b equals to 10. That's the first case. Then second, sigma minimum equals to sigma 0 minus sigma b. Sigma minimum is given 10 raised to minus 4, so we can say sigma 0 minus sigma b equals to minus 4. That is equation number 2. By solving these two equations, okay, we will get the value of sigma 0. Sigma 0 plus sigma b 10, sigma 0 minus sigma b minus 4, sigma b cancels, so 2 times sigma 0 equals to 6, so sigma 0 equals to 3 Newton per mm square. Once we get the sigma 0, now we need to calculate diameter, but as we know that sigma 0 equals to P by A, we already have the value of P, and sigma 0 I will get the value of area, and once I will get the value of area, I can easily calculate the diameter for the circular section. So I am applying sigma 0, that exists, that is P by A. Sigma 0 is 3, P is given to us 100 into 10 raised to 3. I can easily calculate the value of area, that is 33.33 into 10 raised to 3 mm square, and now from the value of area I can easily calculate diameter. Okay, so area stands for pi by 4 d square. Area 33.33 into 10 raised to 3 equals to pi by 4 d square. Okay, so I will get the value of diameter, that is 206 mm. Okay, so in just previous two examples, in both cases sigma maximum and sigma minimum were given to us. In one of the examples we calculated force, while in this example we have calculated diameter. Okay, so see, many of these examples have not been asked in the examination, but just for your concept, say to calculate the maximum and minimum stress in any cross section, and if any of the stress is given and we need to calculate the dimensions, say force, diameter, eccentricity, we need to solve this kind of sums. So that's why I have given this kind of examples over here. Now coming back to the main kind of examples, that is example number 9. So now let's start with example number 9. Now these are the examples which have been continuously asked in the examination in the 7 marks. Okay, so for that one, and this is quite long example also. A raft footing is supporting a vertical load of 150 kilonewton as shown in figure. Figure is given to us. Okay, this one is our force. Compute the stresses at each corner of the pier. Now these are the criteria in which we need to calculate the stresses at each corner of the pier. Draw the stress distribution diagram also, and they have asked us to draw the stress distribution diagram also. It has been asked in 7 marks, May 2016. So first of all, what we need to do, figure is given to us. If figure is not given to us, they will give us description. So right now we can say P is acting over here. So in this one we will get 2 eccentricity. See, just a minute, this is our central point, say regarding longitudinal axis. So this dimension will serve as horizontal eccentricity, that is 1.5, while this dimension will serve as vertical eccentricity, that is termed as EY. So 2 eccentricities are given to us, EX, that is 1.5 horizontal eccentricity, and EY, that is 1.2. Okay, always calculate eccentricity with respect to center. Clear? So 2 eccentricities are there. So now first of all, P, that is 150 kilonewton. okay, and keep in this kind of examples, keep unit as a major units, okay. Do not need to convert it into the smaller unit, means I will keep the force in terms of kilonewton, dimension in terms of meter, because in this kind of examples always units are bigger, okay. So P 150 kilonewton, Ex 1.5, Ey 1.2, then width, that is 5 meter, and opposite direction, that is D, that is 3.5 meter. This is the plan given to us, okay. So as we were doing, so now in this kind of examples sums are quite different, means we need to calculate stress at each corner, say at B, at D, at C, at A. So for that one, three stresses will be there: sigma 0, sigma bx, and sigma by. These stresses will be need to be calculated. So for that one, let's understand their formula first of all, so that we will get the idea that which unknowns we need to be calculated. For example, sigma 0 formula stands for P by A, that is direct stress, there is no difference in that one. But sigma bx, now this formula will be different. Sigma bx formula stands for sigma b, that is m by z. Now we all know that m by z equals to I by y, okay, okay, means z means I by y. Now we need to calculate sigma b in x direction as well as in y direction. So this time we need to calculate with respect to horizontal as well as vertical. So first of all, sigma bx, so formula will be, see, m by z. Now z stands for I by y, okay. Now as we are calculating, let me just zoom the sketch to make you understand the formula, okay. Now as we are calculating sigma bx, so formula of, we can say, just a minute, I, that is with respect to x axis, so we can say bd cube by 12, like that. So I will get sigma bx, so for that one I xx I will take, and opposite of that one, just a minute, let me zoom one just more, okay, okay, sigma bx, okay. So that is m by z. Now z stands for, we can say, I by y. Now I, so I always take I equals to Ixx for sigma bx, okay. So I have taken over here Ixx, and opposite eccentricity will be generated, so ultimately Ey will be there. And with respect to y, we need to y, that is equals to, we can say, d by 2. Say for, as we are taking Ey, so it will be converted into d by 2, like that. So ultimately sigma bx formula will be this one: P into Ey divided by Ixx into d by 2, and exactly opposite of sigma by. Just a minute, see, sigma by, same formula will be there, m by z, z equals to I by y. Now as I told you, sigma by, so as we are calculating with respect to y axis, so I will take over here I by y, okay. Opposite eccentricity will be generated, that is Ex, and as horizontal eccentricity is generated, so its dimensions will be b by 2, that will be over here, see, b by 2, okay, while p will be common. Now in this one, as we have seen over here, see, sigma bx, so I took Ixx, while in this one sigma by, so I took Iyy, clear. Now opposite eccentricity will be generated, so Ixx opposite, that is Eyy, and Iyy opposite, that is Exx. And then for Ey, the Cg will be with respect to y, that will be d by 2, that is over here, you can see, okay. While in this one, with respect to Ex, horizontal eccentricity will be p by 2, that is over here. So hope so you have got the formula, how to generate the formula, okay. You can remember the formula by yourself, just my point is that you need to remember the procedure, how we are generating formulas, okay. So now I need to calculate these unknown parameters, which Ex, Ey, which will be given to us in the data, then P, that will also be given to us in the data, then B and D, that will also be given to us in the data, cross section. What we need to calculate, that is Ixx, Iyy, these are the parameters which we need to calculate, okay. So let's just start the sum, as well as we need area also for the direct axis. See, sigma 0 equals to P by, so like all the previous example, we will do the same manner sum like as we were doing in the previously. Just a minute, yeah, let me keep it in one frame, yeah. So first of all, area, that is B cross D, B and D are there, so I can easily calculate the area, that is 5 multiplied by 5.35, so I will get the answer 17.5 meter square. Then Ixx, that is BD cube by 12, 5 into 3.5 cube by 12, so 17.86 meter raised to 4. Iyy, dB cube by 12, 3.5 into 5 cube by 12, so I got the answer 36.46 meter raised to 4. So I got all the areas as well as Ixx and Iyy. Okay, now I will generate all three stresses. First of all, sigma 0, that is P by A. P 150, area 17.5. 150 divided by 17.5, I'll get the answer 8.57 kilonewton per meter square. That is this one. Then sigma bx, we have already discussed this formula. P into Ey divided by Ixx into d by 2. Now P, that is 150, Ey, that is given to us in the data 1.2, then Ixx 17.86, and d by 2, that is 3.5 by 2. Simplifying this one, I will get the answer 17.63 kilonewton per meter square. Then sigma by, that is this one. Formula already we have generated. P into Ex divided by Iyy into b by 2. So first of all, P 150, B, that is 5, divided by Iyy, that is Iyy, 36.46, like that. And just a minute, b by 2, that is, we can say 5 by 2. By simplifying this one, I will get the answer 15.43 kilonewton per meter square. So finally I got all three answers, sigma 0, sigma bx and sigma by. Now we need to calculate the stresses at each corner. Now over here also there is one rule for generating formula. See, in all three equations you can see three unknowns are there, as we have already seen, sigma 0, sigma bx, sigma by. But we need to apply the sign convention rule for that one. So we will use the quadrant system in this one. Okay, what we will do, say, just a minute, say this one is our quadrant, but normally in surveying you always got the quadrant like this, 1 2 3 4, like that. In MOS we can, or we can say in maths, we are calculating some like this, 1 2 3 4. But in this one we will calculate vice versa. 1 will be over here, 2 over here, 3 over here, and 4 will be over here. Just to remember the formula, nothing else. So in the first quadrant it is always plus plus, in the second quadrant that is minus plus, third quadrant minus minus, and fourth quadrant means plus minus. Okay, now the first term means we are using two terms. See, two terms are there, like that. Now out of this two term, first term is sigma bx, while the second term is sigma by. While sigma 0 will always be positive, there is no problem with that one, sigma 0. Okay, so for that one, what we will do in the first quadrant, that is at B. See, this one is our point, that is our first quadrant. Okay, so in the first quadrant our formulas will be, as I told you, say plus plus. So sigma 0 is always plus, sigma bx plus, sigma by plus, like that. Then second point, that is C, that means this is our second quadrant, that is minus plus. So at corner C, formula will be sigma 0 is always plus, sigma bx, that is minus, and sigma by, that is plus. Then D point, that is our third quadrant, that is minus minus. See, formula at corner D, sigma 0 is always plus, sigma bx is minus, sigma by is minus, that is this one. And A, that will be our fourth quadrant, that is plus minus. So at corner A, sigma 0 is always plus, sigma bx plus, and sigma by minus. So hope so you have got the concept of the formula, how to generate this formula. As I told you, you can remember formula by yourself also. Okay, this is just a technique which I am using to remember this kind of formula. Let me repeat once again. Four quadrants are there. First one, second one, third one, and fourth one. First plus plus, second minus plus, third minus minus, fourth plus minus. Okay, first term is always sigma bx, and second term is always sigma, just a minute, second term is always sigma by. These are the terms. While sigma 0 is always positive, there is no problem with sigma 0. Okay, and giving the name, this one is our B point, this one is our C point, this one is our D point, and this one is our A point. You can take screenshot of this one and remember the formula. Okay, So now at corner B, as we have already discussed, okay, formula will be sigma 0 plus sigma bx plus sigma by. Just let me keep it in one frame. Sigma 0 bxy, yeah. So sigma 0 plus sigma bx plus sigma by. Sigma 0 8.57, sigma bx 17.63, and sigma by 15.43. So ultimately by solving this one I will get the answer 41.63 kilonewton per meter square, and as it is positive, keeping it as a compressive stress. Okay, then at corner C, this one means second quadrant, minus plus sigma 0 minus sigma bx plus sigma by. Sigma 0 8.57, sigma bx that is 17.63 minus, and sigma by that is plus 15.43. Solving this one I will get the answer 6.37 kilonewton per meter square, and again as it is positive, so compressive stress. Then at corner D means third quadrant, negative, minus minus, sigma 0 minus sigma bx minus sigma by. Sigma 0 8.57, sigma bx 17.63 minus, and minus sigma by that is 15.43. By solving this one I will get the answer minus 24.49 kilonewton per meter square, and as it is negative, so it is a 10 Celsius. And lastly at corner A, that means fourth quadrant, plus minus. So formula will be sigma 0 plus sigma bx minus sigma by. Sigma 0 that is 8.57, sigma bx that is 17.63, and sigma by that is minus 15.43. I will get the answer 10.78 kilonewton per meter square, as it is compressive, so that is, sorry, as it is positive, it is compressive. Usually all these three stresses will be compressive normally in 99% cases, while at corner D, that means third quadrant, that is always negative. Now we need to draw this sketch. Now how to draw a sketch? So for that one also the similar parameters is there. Just a minute, there is no written rule for that one, I have made my rules. Okay, so first of all what we need to do, we need to do the rectangle cross section. Then what we need to do, we need to draw a parallel line along all four sides, see, like this. Okay, now starting with the value sigma at B corner, value is 41.63 positive. Okay, just a minute, yeah, let me keep it one frame so we will get the value. Okay, I need to draw the diagram once again. See, first of all, as I told you, just a minute, first of all draw the cross section, then draw a parallel line along all four sides, like this, like this, like this, and like this. Okay, now just a minute, let me draw properly, like this. So first of all at corner B means this one. Okay, just a minute, corner B, so value is 41.63, as it is positive, so let's move towards the right hand side, 41.63. if it is negative, then we will move towards left hand side, like that, but right now it is a positive. Then at corner C, that is this corner, value is again positive 6.37, so let's move towards the right hand side and join them. Okay, that is this portion. Now C point will be common over here also. Now as it is positive, move towards the down, if it is negative, then move towards the up, like that. Then at corner D, this point, value is negative 24.49, as I told you, negative, then move upward 24.49 and join them, like this, plus minus, over here both values are plus. Clear? Then D point will be common in this one also. Okay, so as it is negative, move towards the right, otherwise we have moved towards the left hand side if it was plus. Okay, then at A, that means this corner, value is 10.78, so let's just move towards the left as we discussed and just join them. One, this one is negative, this one is positive, like that. And then going at the A point is common in over here also, at A 10.78, if it is positive, go upward. Okay, and over here point B, so that's value is 41.63, as it is positive, going upward, and then just join them together, like this. Clear? So this is our diagram. Okay, always draw diagram on this concept only. If you need sign convention, then just let me draw. Okay, I am just drawing sign convention rule. Okay, for that one, if it is positive, move towards this side. If it is negative, move towards left hand side. Okay, and this one is right, this one is left side. And in the bottom, if it is positive, move towards right hand side, positive, and if it is negative, move towards upward side, like that. Then in this one, if it is negative, move towards left hand side. If it is positive, move towards left hand side, or right and left. Okay, and in this one, if it is positive, move towards upward direction, and if it is negative, move towards downward direction. See, so this is the criteria which will be followed to draw the diagram. You can take screenshot of that one. Okay, I have shown all the four sides parameters. This one is for this side, this one is for this side, this one is for this side, and this one is for this side. Then these two sides will have vice versa relation. See, these two, while these two will have vice versa relation. Okay, so hope so you have got the concept. Okay, so this was the example. Okay, if they do not ask to draw the diagram, then you don't need to draw this diagram. Okay, like that. Then okay, just a minute, let's move towards another example. So these are the examples which have been asked in the 7 marks. Example number 10, a masonry pier, just a minute, let me take another pen. Yeah, a masonry pier 3 by 4 meter supports a vertical load 100 kilonewton as shown in figure. Figure is given to us, load is over here. This will be horizontal eccentricity Ex, see, 1 meter, and this will be vertical eccentricity Ey, that is 0.5 meter, like that. Both eccentricities are given to us in the figure. Dimensions are there, 4 by 3 meter. So B and D, B4, D 3 meter. Then find the stresses developed at each corner of the pier. So we need to calculate stresses at each corner like previous example. And now in addition they have asked something else also, what additional load should be placed at the center of the pier so that there is no tension. So what extra load we need to apply at the center, so tension will not be produced in the section. Okay, so what we need to do, we need to solve the previous examples. We will need to do the same procedure as like previous examples, and in addition we will need to do one more little step also. So as we were doing in the previous examples, what we will do, first of all, area Ixx Iyy, area rectangle section 4 into 3, that is 12. Ixx BD cube by 12, so 4 into 3 cube by 12, say 9 meter is to 4. Iyy dB cube by 12, 3 into 4 cube by 12, 16 meter is to 4. Clear? Then now we will calculate our three stresses. Sigma 0, that is P by, just a minute, yeah, sigma 0, that is P by, now P 100, area is 12, so 100 by 12, I will get the answer 8.33 kilonewton per meter square. Sigma Bx, formula stands for P into Ey divided by Ixx into d by 2. We have already discussed these formulas in the previous example, so I won't discuss over here. I will put down the value directly. So first P, that is 100, Ey, that is 0.5, Ixx, that is 9, into d by 2, d is 3 meter, that is 3 by 2. By solving this one, I will get the sigma Bx 8.33 kilonewton per meter square. Then sigma By, formula will be P into Ex divided by Iyy into B by 2. So first of all, P, that is 100, Ex, that is 1 meter, okay, Iyy, that is 16, into B by 2, B is 4 meter, that is 4 by 2. Simplifying this one, I will get the sigma By, that is 12.5 kilonewton per meter square. And as we have already discussed, we need to calculate all four stresses at each corner. So as we have already discussed, at corner B, first quadrant, plus plus, right? So sigma 0 plus sigma Bx plus sigma By. Sigma 0 is 8.33, sigma Bx is also 8.33, and sigma By, that is 12.5. Let me just keep it in one frame so you will get it very easily. Yeah, now see, sigma 0 8.33, sigma Bx is also 8.33, and sigma b by 12.5, all are plus. So I will get the answer 29.17 kilonewton per meter cube, as it is positive, so compressive stress. Then at corner C, that means second quadrant, that is minus plus. So formula will be sigma 0 minus sigma bx plus sigma by. So 8.33 sigma 0 sigma bx minus 8.33 and sigma by plus 12.5. This will be cancelled. So ultimately answer 12.5 kilonewton per meter square, as it is positive, so compressive stress. Then at corner D, that means third quadrant, minus sigma 0 minus sigma bx minus sigma by. 8.33, that is sigma 0, sigma by is also minus 8.33 and sigma by, that is minus 12.5. Simplifying this one, I will get the answer minus 12.5 kilonewton per meter square, and it is negative, so it is tensile. And last one at corner A, fourth quadrant, that is plus minus sigma 0 plus sigma bx plus minus sigma by. Sigma 0 8.33, sigma by 8.33 and bx 8.33 and by 12.5. Let's put down the value. I got the answer positive 4.16 kilonewton per meter square, as it is positive, so keep it as compressive. And then we need to draw the diagram. So but before drawing the diagram, they have asked us for additional load at the center. Okay, so what we will need to do to calculate the additional load, first of all we need to see where tensile stresses are produced. So tensile stresses will be produced only at D, this one, third quadrant. Okay, so what we need to do, see, to avoid the tension at the corner D, apply the additional load P1 at the center to produce the additional compressive stress. How much? So that is at D, 12.5 kilonewton per meter square. So what we need to do, we need to apply the formula of sigma 0 only. Sigma 0 equals to, we can say 12.5. Now we know that sigma 0 equals to P by, but we need to apply P1 by A. Okay, equals to 12.5. Okay, see, I have done, that is the same thing over here. See, sigma 0, that is equals to this 12.5 means the tensile stress. It is the only tensile stress out of 4 folds. See, this one is positive, this one is positive, this one is positive. This is the only one which is tensile, that is negative. So I need to take this stress over here. Okay, so P1 by A equals to 12.5. P1 by A means nothing, we can say it is a direct stress, sigma 0, like that. So P1 by A equals to this one, minus 12.5, keep it as a positive over here, 12.5. So P1 equals to 12.5 into area. We have already calculated area, 3 into 4, that was 12. So by simplifying this one, we will get the answer, that is 150 kilonewton. So to avoid the tension at the corner D, we need to apply this 150 kilonewton force at the center. Okay, so if it is asked, then and only we need to do this one. In the previous example they didn't ask us, so we didn't do this one. Okay, in the previous example. Now talking about diagram, I've already told you the rules for drawing the diagram. Okay, so in this one I will draw directly. See, 29.17, as it is positive, go towards the right hand side. This is corner B. Then at corner C, 12.5 positive. At corner C, 12.5 positive, go right hand side, this one. Okay, now coming towards the bottom, as it is 12.5, going downward. Then at corner D, that is over here, minus 12.5, minus, then we will go upward like this, join this one. Okay, a minus plus, this one is both plus. Then in this side, 12.5 negative, go towards the right hand side. And at corner A, as it is positive, go towards the left hand side, join this one, plus minus. And then at upper side, see, at corner A, as it is positive, go towards the up, and at B it is 29.17, again positive, go towards the up, like this. Okay, we have already solved these rules in the previous example, so right now I am putting down this value, okay, directly. And then the last sum of this type of sums, example number 11. See, a rectangular column section ABCD having side ABCD equals to 50. So AB, that is this one, and CD equals to 500 mm. They have not given us figure. Okay, so we are drawing figure by ourselves. And BC and AD equals to 300. AD BC, that is 300. So rectangle section is there, 500 cross 300 mm. Okay, carries a compressive load of 200 kilonewton at corner B. So at corner B, a force is there P of 200 kilonewton. Okay, so find the stress at each corner ABCD and draw stress distribution diagram for each side. So we need to calculate stresses at each corner and also need to draw the diagram. Now as force is acting at corner B, our horizontal eccentricity will be like this, Ex. So that will be total 500, we can say divide by, we can say 2. So Ex, see, 500 divided by 2, that is 250. Similarly talking about Ey, then it will be this dimension, right, Ey. So overall dimension divide by 2. So that is Ey equals to 300 divided by 2. See, I have always said calculate eccentricity with respect to center. Say this dimension is called Ex, okay, while this vertical dimension from the center is known as Ey, while this one was Ex, like that. So we got the value of Ex, Ey. Then force is also given, that is 200 kilonewton. Say 200 into 10 to 3 Newton, and B and D are also 500 cross 300. So as we were doing in previous two examples, we will do the same way. Area Ixx Ryy. So first of all, area B cross D, 500 cross 300. So I will get the answer 150 into 10 to 3 mm square. Ixx rectangle section BD cube by 12, that is 500 into 300 cube by 12. I will get the answer 1.13 into 10 to 9 mm to 4. And Iyy dB cube by 12, that is 300 cross 500 cube by 12. I will get the answer this way. Clear? So now let's calculate three individual stresses. Sigma 0 P by 200 into 10 to 3, that is P. Area 150 into 10 to 3. I will get the answer 1.33 Newton per mm square. Sigma Bx, that is we have already derived this formula, P into Ey divided by Ixx into D by 2. P, that is 200 into 10 to 3. Okay, let's put down the value, just a minute. That is 200 into 10 to 3. Then Ey, that is 150 over here, divided by Ixx 1.13 into 10 to 9 into, we can say D by 2. D is 300 by 2. By solving this one, I will get the sigma Bx, that is 4 Newton per mm square. Then sigma By, we have already derived this formula, P into Ex divided by Iyy into B by 2. Okay, so first of all, P, that is 200 into 10 to 3. You can get 200 into 10 to 3. Ex, that is 250, that is 250. Iyy, that is 3.13 into 10 to 9, and into B by 2, that is 500 by 2. By solving this one, I will get the value of sigma By. Okay, so now let's solve the each and every corners example. Okay, just a minute, let me keep it in one frame so that we will get the value properly. Yeah, so first of all, at corner B, first quadrant, plus sigma 0 plus sigma Bx plus sigma By. Sigma 0 1.33, sigma Bx 4, and sigma By, that is also 4. Simplifying this one, I will get the value 9.33 Newton per mm square, as it is positive, so we can say compressive. Then at corner C, that is second quadrant, minus plus. Formula will be sigma 0 minus sigma Bx plus sigma By. Sigma 0 1.33, sigma Bx 4, and sigma By 4. Simplifying this one, I will get the answer 1.33 Newton per mm square, compressive. Then at corner D, that means third quadrant, minus sigma 0 minus sigma Bx minus sigma By. Sigma 0 1.33, sigma Bx minus, that is minus 4, sigma By minus, that is 4. Okay, so simplifying this one, I will get the answer minus 6.67 Newton per mm square, tensile. And last one, at corner A, means fourth quadrant, plus minus. Sigma 0 plus sigma Bx minus sigma By. Sigma 0 is 1.33 plus sigma Bx, that is 4, minus sigma By, that is 4. So I will get the answer 1.33 Newton per mm square, as it is positive. So compressive. See, in the previous two examples, units were in terms of kilonewton and meter, while in this one, in the data, they have given the dimension in terms of mm. Okay, you can see over here mm. Okay, so I have keep each and every term in terms of Newton per mm square, like that. And at the end, we need to draw the diagram. Okay, just a minute. Yeah, so first one, at corner B, say positive then right hand side, negative then left hand side. At corner B, 9.33 positive, and at C 1.33 positive, join them, positive. First case, bottom, positive then downward, negative then upward, positive 1.33 at corner D, negative 6.67, join them like this, plus minus. Then over this side, if it is positive then left hand side, negative then right hand side, negative 6.67 at corner A 1.33 like this, join them, negative positive. And towards the upward side, say at corner D at A 1.33 positive, so upward side, and at corner B 9.33 upward side. So this will our diagram. Okay, so hope so guys you have got all the concept of this kind of examples. This is the first type of examples. I will cover the another two type of example in the coming next videos, otherwise videos will be quite longer. Okay, so right now myself Gaurang Prajapati signing off.